All right. So, no, there was no homework for today. So I mentioned that we were going to try to get a monster in our dungeon and have him start wandering around on his own, like he has a mind of his self, um, a mind of his own. Just to kind of give you a little preview for Friday, as we start looking at transitioning to Unity, we are going to store our dungeon information inside of something called JSON and then read it into our program. This format is the format that every modern online API uses. So we're going to learn how to work with JSON objects and bring it into our program, and we'll talk all about that later, but that's the direction we're going. So, because that question came up, I think, a couple classes ago, where no longer will we be doing all this junk to build our dungeon. We'll have a parser that will effectively do all that, but it's going to read in from a document that looks like this, that describes all of our dungeon that maybe a non-programmer could have written, or maybe there's a tool that allows them to generate this, so that our program reads in it. But that's where we're going. That's not what we're looking at today. So what we're looking at today is right now we're putting a player into our dungeon and we're making them walk around, right? We're saying north, south, east, west, whatever to move around the dungeon. So we want to kind of pause our player for a minute and now be able to see our dungeon through the eyes of a randomly wandering monster. All right. And this is going to kind of bring our different tools together, like threads and things like that. Let's see. So let's go ahead and create a monster as a starting point. So monsters are going to be a lot like players, where they're going to have a name. Long term, maybe they'll have hit points, they'll have strength, they'll have armor class. They also will know about the room they're in. So when we build a monster, maybe it gets built a lot like a player. Set current room, get the current room, whether the monster's dead, take damage. Really, it seems like a monster is a player. So what we're going to do is we're going to add a new class called monster.java. And this guy will be public class monster. And we're going to say this extends player. So we want a monster to be everything that a player is, but we're going to build some stuff into it to allow monsters to make some decisions for themselves based on the room they're currently in, without us having to type stuff in what we want to have happen. All right, so we'll make our constructor here. So the constructor for monster will say initially is going to take in a string name. I think that's all we took in for player, right? Yep. And then since our player constructor already does a lot of this stuff for us, actually does everything for us in this current case, we're going to go ahead and just call upon our parent's constructor, passing it that name. So a monster is a player, and the player constructor already does all the stuff we really want to have happen for a monster. Now, historically, this was from last term, we had already made these variables protected, which means that they're accessible to the player class as well as things that are children of player. We probably want to go ahead and make the player's current room also protected so that monsters can have access to the room they're currently in. All right, so just that one little change makes all the fields now available to our monster class. All right, so let's just hold monster there for a second and then go ahead. Super is how an object refers to its parent from within itself, just like this is how an object refers to itself from within itself. For monster, super is the instance of player behind it. Okay, yep. But this particular syntax for using super if this is how you call the constructor for your parents, as opposed to saying things like super dot get room or something like that. It will. It will. Just this is a special use right here. This use is identical to the this keyword. The difference being, are we accessing fields and fields and functions that are owned by our parents, or are we accessing our own unique stuff? That's when we decide whether to use super or to use this, because sometimes those can work together. Where this first line here, this is a special use of it that has to be the very first line of your constructor if you intend to use your parents' constructor. Good.
Like this example only has one parameter, but if it had more, then in monster, when we call super, would that also have like?
Yeah, you got to pass it whatever this guy's expecting. Effectively, this very first line here, this guy right here, whatever we pass in here has to match up to what this guy's expecting. Yeah, if he takes in 30 parameters, you come up with your 30 parameters to send in there. But yeah, good question. Okay. So we will go ahead and let our parents constructor do the heavy lifting for us. We'll go ahead and let our monster class kind of evolve as we see a need to have monsters differentiate themselves from players. As of right now, a monster is exactly a player, right? Um, they just by a different name. Monster and player are synonyms to each other. All right, so now let's go ahead and kind of in the same light as we did for our players, let's go ahead and allow our room to also house a single monster. I know long term we might want to have this multi-user dungeon where also we have like a collection of monsters that could be in a room, a collection of players that could be in a room, all this stuff. We're keeping it simple initially, where a room, as it currently stands, can hold a single player. Now we're going to teach it how to also potentially hold a monster. So inside of our room, we'll go ahead and add another field. Private monster, we'll call this guy the monster. Minimize some of these things to make it a little bit easier to look at. All right. So we already have the ability for a room for somebody externally, because it's public, to set the player for this room. What we want to go ahead and do is we want to add something similar for setting the monster. So we'll have a public void set the monster. This guy will take it a monster, the monster as a parameter. And we'll go ahead and set the monster field equal to whatever was passed in, currently with no oversight. So now somebody externally can also let this room know if there's a monster that's going to be in there. All right. Now, since now our rooms could hold monsters, we probably also want to update our display method to not only show the players that are in the room, but also the monsters that are in the room. All right. So if we go to our display for room, we print out the name of the room. Then we say, hey, if there's a player, go ahead and print out also here, the name of the person or whatever. Well, now we also want to have a monster check to see if there's a monster in the room. Now we can decide, do we have a line that says also here that only has players in it, that a different line that also shows the that shows the monsters, or do we put them all on the same line? To keep it simple, let's just do a separate line so we don't have to go and reinvent the wheel for this. So also here, so why don't we just call this guy other players. Here, we'll have a player name. Right, and then let's do something pretty similar here for monsters. So we'll steal this code and doctor it up a little bit. So we'll say if the monster is not equal to null, that means somebody has put a monster into this room. Then we'll go ahead and say, what? Monsters here. Enemies. Enemies nearby. Yeah, no, thank you. Really? How do you spell nearby? Like that. All right, so we'll put that in there. And why don't we say just none? All right, so say this again. Um, we're not going to use the player's name for the monster. We're going to be using the monster. Yep. So the monster, we'll call his get name. Notice when we look in monster, we don't have any of that stuff in here, but a monster is a player. So we got to go back to player. We see that we have a get name somewhere in here, right here. And this guy needed to at least be, let's see, we were just in room. He needs to be public in order to access it. All right, so making this public doesn't matter which instance of an object we're in. We have access to this, but we're calling the monster's version of get name, which he inherited from his parent, which is player. All right. So that's what we do if there is a monster in the room. All right. Now, for right now, there are 0 monsters in our rooms. In fact, we haven't done anything with monsters except build in the ability to represent monsters, right? So if we go and run our program right now, it should work the same way it worked currently because we're not actually building monsters. We support monsters currently. So let's go ahead and confirm that that is the case and make sure we didn't break anything. Right, so we can move around. All right. So now let's actually put a monster into our dungeon. When we go back to dice, I'm sorry, dice. When we go back to driver, wherever driver is. Oh, where is driver? Oh, it's just hidden from me. Uh, hmm. All right. So in this guy, we're creating our player. We created our dungeon, passing in that player. We can go ahead and do that with our monster as well. So that means we're going to have to teach our dungeon how to not only take in a player when you're building a dungeon, but also take in a monster. Say this again. You mean the parameters that are coming in here? Yeah. So we're going to take one additional thing. We could also just build our monster inside the constructor. In fact, if we're going to randomly put a monster in one of the rooms, maybe we actually do that. So actually, let's just do that. Let's build our monster here in the dungeon. We'll initially put him in room 1 so that we see them right away. So we know that that part's working. And then we can randomly put them somewhere in the dungeon and then tell them to start wandering around effectively. All right, so here in our dungeon, after we create our rooms, we'll go ahead and say monster, the monster is equal to new monster. Okay, what kind of monster do we have? Troll. Maybe just so it looks good on the screen, we'll just call it a troll. So it'll say enemies here, a troll, something like that. All right. So we have our monster. Now we want to go ahead and add that monster to our room. We're going to put it in room 1. So let's go back and look at our room, make sure rooms can accept monsters. So a room has a monster. We've built in this ability to set the monster for that room. So we're going to go ahead and call upon that. We just wrote that a few minutes ago. I'm going to how do I get this to slide? I have to click and pull. It's not too. Oh, I got to swipe on a Mac apparently. All right. But we're doing this inside of Dungeon anyway, so I didn't even need to go there. So we're going to say room 1, we want to set the monster to the monster we just built, which is our troll. So we'll just go ahead and toss them into room 1. All right. Now when we go and run this, we should see that we have enemies here, and it should say enemies nearby, we have a troll. All right, so now our rooms hold on to 2 entities. We have a player, potentially a player in the room, and potentially a monster in the room. This guy right here. Identical to what we had for set the player, just it sets a different field. So right now I'm in that first room, R1. If I go ahead and move my player to the north, we should see that the troll did not follow us along. He's still in that first room. So enemies nearby says none. If we go back to the south, then we have the troll. Okay, presumably trolls would be aggressive. So in a real game, as soon as we walked in the room, the troll probably would attack us. But we're not quite there yet. All right. So, any questions about getting our monster into the game where monsters currently are just like a player? Go ahead.
Where instead of having the monster be a physical creature that moves around the dungeon, just like have a set chance that when a player enters a
Absolutely. Yeah, so kind of old school Final Fantasy, where when you used to need to power level your guy, you just wandered around until monsters fired up. So what he suggested is, could we have it when a player first enters a room? Could we kind of have like a dice roll that determines if a monster happens to be there with you or not? We certainly could do that. Because we want this guy to kind of wander around like he's a bot, let's say. Let's treat him like a normal player, but absolutely, as a programmer, you can do whatever you want effectively, right? Which then allows you to get creative with your applications when you get this skill set under your control. All right, so we have a monster in room 1. Now, what I want to effectively do is, let's say that every 2 to 5 seconds, something like that, the monster potentially takes an exit, wanders into a different room, potentially. How might you go about doing that based on what you know right now? Go ahead. Okay, what are we setting a delay for? Okay, well, so let's go this route. Do you think we need to have a thread involved here? Because really we have, at this point in our game, we have 2 entities, right? We have the main thread, which we're in control of, right? We're logging in and we potentially want to be able to still walk around our dungeon like we're doing now. But we also want to have this secondary thing going on where our monster has a mind of its own and might be wandering around the dungeon that is happening separate from us. If we try to do both of those things in the main thread, then only one thing can happen at once. As long as it's waiting for us to make our move, or take an exit or whatever, our monster's not going to be able to make any decisions on its own. So we could say, well, as soon as the player enters something and presses enter, then we go ahead and quickly roll the dice and see if the monster goes somewhere else. But that's not going to feel bad. Great. We want to kind of experience the idea that we're standing there and all of a sudden monsters go wandering in. Yeah. He already has stats because he's a player. So right now a monster is identical to a player. There's no he gets everything that a player has. Um, all right. So we probably need to have a thread. That kind of is the heart of our monster. So if you want to think about this, previously we had made these worker bees, right? And so inside the worker bee, we maybe gave it a couple of parameters or something like that. And we told it to go. In this case, the job of our thread is to, move our monsters around potentially, right? So we need to build a thread that knows how to hold on to, at the very least, the monster. So let's go ahead and implement another thread. I'll go ahead and stop this. So let's call this guy monster controller. All right, so this is going to be the thing that controls our monsters. So public class monster controller. Now we want this guy to be a thread, which means we're going to say this guy extends thread. So now he is a thread, which means he has a run method that does nothing, and he has the magical start method that does the magic that we don't want to break. So we know at the very least, if we want this guy to do something, we're going to have a public void run function here that does our special monster stuff. All right. Now, we're also going to need a constructor for this guy. Public monster controller. We'll leave it with no parameters for the moment. All right. So if I'm a monster controller, so imagine that you're this instance of monster controller, and your job is to move monsters around a map. What are you going to need access to in order to do that? Well, at the very least, you're going to need the monster that you're in charge of controlling, right? So at the very least, we're going to need a private monster, the monster. All right. Now, whoever creates this thread, this monster controller, they're going to have to provide this guy through the constructor, the monster his job is to control. So we'll go ahead and take in as a parameter the monster. I will say this dot the monster is equal to the monster. See how handy IDEs are, as bad as my spelling is, as long as it's already in there. I look like I know what I'm doing. Otherwise, it's like a third grader. All right. I'm actually not a bad speller. I just type very fast, so my brain gets ahead of my everything else. It's a curse. All right. So we now have a monster controller that has a monster that he's going to go and do some stuff with. So who's going to go ahead and start this guy up? Kind of turn the engine on for our monster. Well, let's go back to our constructor and dungeon where we created our monster. So we created an instance of monster, not a monster controller. We just have a monster here. And we went ahead and threw him in room one. Just we put him in the same place as we put our player. But now we want to go ahead and we want to create an instance of monster controller. And this guy's going to be a new monster controller, passing it the monster. All right. So this is kind of like Frankenstein's monster, right? We have his controller, we've thrown our monster in there, and now we're gonna do the lightning strike stuff and bring it to life. And we're gonna bring this guy to life by saying MC dot start. That's how we start a thread. So, and monster controller is a thread. So MC.start is going to do the behind the scenes magic on our operating system to create a thread so that this guy does not block. Our player can go and keep doing its current thing I just go ahead and hit run right now, we have a legitimate monster controller that holds a legitimate monster that has a run method that does nothing. So our monster thread is already dead. But our player is not blocked from going and doing his own thing. If we want to further show that, what we could do is go into our monster controller, and inside of run, we can just put in a while loop, say like while true, and let's go and remind ourselves about the Java thread class. I mentioned a little bit ago that maybe every 2 to 5 seconds we want our monster to do something potentially. So let's remind ourselves how we can make a thread go to sleep. So we'll go through, we're looking at the features of threads here. And one of these features is called sleep for some number of milliseconds. So 1,000 milliseconds is 1 second. For right now, just to test this real quick, why don't we just say for every 1 second, so it sleeps for a second and then says I'm still here or something like that. So we kind of know that monster is still kicking. All right. So inside of our monster, just forever, he's going to go ahead and say red dot. Oh, just so we can practice here. Here's our sleep function right here. Takes in a number of milliseconds. Notice it's static. We call static methods using the name of the class in which they were defined. So this is not an instance method of threads. This is a class method of threads. So we will say thread dot sleep. I'll just put in 1,000 for right now. And then we'll do something like system.out.println monster still here, something like that. So we'll get a little banter. Every second, something's going to pop up on our screen as our player is still able to wander around our dungeon. All right, so this now means our thread for our monster just does this forever. He's just chilling there, and every 1 second he says something, prints to the screen. Go ahead and run this. Oh, remember, we got our exception handling. We'll be good. And we can see that if we go into the documentation, we click on sleep. We see that this guy throws something called an interrupted exception. We're not going to care about the specifics of the type of exception, but since this guy throws an exception, we have to try to go to sleep. So inside of run here, we will just throw a try. We'll throw the couple of things that we want to do, that we're trying to do. That's this. Right. And then maybe in here we do system.err.println. Something went wrong with our monster thread. And we hope we never actually see that. Whatever, yeah. The exception it gets was called an interrupted exception. So when this can happen is when a thread is asleep, if some external aspect of your application happens to interrupt this thread, maybe try to kill it off, try to send it a notification, something like that while it's sleeping, that exception will be raised, and then we could handle it. So this could actually be part of the logic of your program. If you allow your monsters to go to sleep for some period of time, but then some other part of the program wants to send that monster a message, the monster will then wake up, be able to receive that message, and we would deal with that inside the catch here. So kind of the important thing is don't necessarily assume that exceptions are always errors. We can look at them really as being an opportunity to deal with some kind of occurrence rather than the program just dying. All right. Doesn't mean you're always going to crash the program. You might say, oh, thanks for letting me know that that went down. I'm going to now handle that, and program will just keep going. We'll loop back up to the next time through the while loop and try to go back to sleep. All right. So we need to try to do this and then catch the potential exception. I'm catching the generic type of exception called an exception. That's kind of like object in the Java language, where our monster is an object, while our monster is a player, which is an object. In this case, the type of exception that this particular thing does potentially throw is an interrupted exception. And if I click that, you see that that guy is an exception. So we're just choosing not to deal with the specific type of exception, since we might have 5 things, let's say we're doing a whole bunch of stuff inside this try. You could have 5 different things that are happening in there that all throw exceptions of different types. And you might want to be able to handle those individually. So then you could say, I want to catch an interrupt exception. I want to catch a file not found exception. I want to catch, that's when you would get specific. So you can have multiple catches with a single try. Where in this case, we're just saying, look, I want to catch everything in one place, and I'm not even going to look at it. I'm just going to say something went wrong. Now, I'll just throw one more thing out here. I don't remember if I introduced this before, but one thing you can do is with a try catch, like I mentioned, you can have multiple catches. Just put them right after each other, catch, 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 and just make sure they're catching a unique type. But you can then also have something called finally. Whatever you put in here happens every time, whether an exception occurred or not. So if you do have some logic that you need to make sure occurs, you can throw a finally in there so that maybe as your program is dying off, it saves the current state to a database or something like that. You can throw logic inside of a finally. Go ahead. Oh, okay. All right. In this particular case, we don't really have a use for this. So just throw it in your notes somewhere that try catches can have multiple catches, and there's also a finally. I'm not going to test you on it, but every single modern language has this. They all have exception handling. They all have the ability to catch different exceptions. They all have your final, as I'm dying, my death knell is to do this finally thing. Yeah. Say this again. MIPS. MIPS is a CPU architecture. Well, I mean, you're actually the wrong person. I don't get the question. I mean, MIPS is a CPU. What are you asking? Well, I mean, that wouldn't really exist at the processor level. So a MIPS processor is like an Intel processor. Yeah, I mean, it would be the operating system that lives on top of that. You know, a CPU is not really in charge of, the CPU just does whatever you tell it. It's like a running motor, if you will. Yeah. All right. So that's what we're doing in run right now. He sleeps for a second, tries to say something. I doubt we're going to see this at all. So go and run this again. After a second, we're going to see our monster spit something out. That second's going real quick, isn't it? But I can still walk around my dungeon. That monster's just doing his own thing in the background, messing up our view here. But he's happening independently of us. All right. So far, so good. So now let's have our monster do something other than just sleep and say something. All right. So for right now, just because that was happening reasonably quickly, let's say every 2 seconds, the monster might pick an exit. So the monster's currently sitting in room 1 because we know we put the monster there. So every 2 seconds, we want to decide whether the monster is going to take an exit or not. Okay, how would you implement that? How would you randomly decide whether you're going to do something or not? Just making a decision, true or false. Am I going to try to leave this room? How would you handle that based on what you know right now? Go ahead.
So space roll.
Flip a coin, roll a two-sided die. I can also show you if we go to the Java random class. Let's do it that way. What we've used from there is next int. There's also a next Boolean that'll just give us a single true or false. But he just wanted to repurpose our dice. We already wrote it. So we can say dice D equals new dice, two sides, roll. If it's a 0, maybe we do something. If it's a 1, we don't, whatever, something like that. But just to show you here, there is a next Boolean that just gives us a random true or false. Okay. It really doesn't matter which of those we write. Chances are under the hood, it's doing basically what we're doing here. Let's just go ahead and use our class we already built, like he suggested. So what we're going to do here, let's go ahead and have our monster stop saying stuff. After 2 seconds, we're going to create an instance of random. Sorry, we're going to create an instance of dice with 2 sides. Just a reminder, we wrote dice. A dice takes in a number of sides. It goes ahead and has builds all the stuff it needs for its random number generator, and then we can ask that guy to roll. So this is going to give us, every time we roll this two-sided die, it's going to give us a value of 1 or 2. That's how we currently have it set up to work like a 6-sided die would give us 1 through 6. So we'll go ahead and say int val is equal to d.roll. Val is going to be a number that'll be either 1 or 2. So why don't we say if it's a 1, we're going to try to leave the room. If val is equivalent to 1, leaving the room, we'll just verbalize it at this point. Otherwise, it must be a 2. Input. All right, go ahead and test this. So every 2 seconds, let's actually switch it back to 1 second, just so we don't have to wait as long. So every 1 second, our monster's going to flip a coin and then tell us what it intends to do. All right, so hopefully we get a little bit of randomness out of this. He's leaving the room, he's staying put, he's leaving the room, he's leaving the room, staying put, yada, yada, yada. Okay. Well, so now, instead of verbalizing this, we only want to do anything if he's going to leave the room, right? So really, we're not going to do anything in the else. Only if it rolled a 1 are we going to try to leave the room. So what does it mean to leave the room? Well, it means that we're going to take one of the exits for this room, right? Well, who holds the exits for a room? Go ahead. Dungeon holds the rooms. The rooms hold the exits. Yep, room class. So here in our room class, we have a collection of available exits. Now, we know that some rooms only have 1 exit. Other rooms might have as many as 4 exits. The actual number of exits in the room will be Kerr number of exits. So my question would be if I want the player to take, if I want the monster to take one of the random exits, how would you go about that given our current implementation? Go ahead.
Dice object that's limited to that's limited to the size of the array.
Okay. So the size of the array being, so regardless of where we put this, we would create a dice object with this number of sides. So if there's 3 exits, it would be okay. And when you roll the dice, you just pick the exit based on that number, probably the number -1, since we know our arrays are 0 indexed. So if we roll a 3, give us bucket 2. If we roll a 2, give us bucket 1, so on and so forth. All right, so where can we put this? So who's going to do this dice rolling? Okay, so let's go to the monster controller class. So we already have a 2-sided die. So you want to create a dice. Call this which exit. Which exit. This is the new dice. How many sides is he going to have? Okay, but Kerr number of exits lives inside of room. We're currently in monster controller. So how can our monster controller get access to the current number of exits of the room that he's currently in? Go ahead. Well, we already have an instance of the room. If we look at monster, so let's follow the yellow brick road here. Do we all agree that our monster controller knows about the monster that it's controlling? Okay, so he has control of this monster here. Now, if we go into monster, does monster know about the room he's currently in? Well, not obviously, but monster is a player. So if we go and look at player, however I get, no, don't leave. If we go look at player, we see that a player does know about the room they're currently in. So in actuality, a monster does know about the room they're in. Now remember, in room, we had the ability to set the player, but we also today wrote this ability called set the monster. And set the monster went ahead and let the room know about this monster. But if we remember from set the player, we also let the player know about the room they're in. So I have the monster. Can I say this dot the monster dot set the current room to this? We go and look at monster. Does monster have a set the current room? Monster is a player. So yes, we don't see it just laying out here, but because he's a player, we have to go and look at player to see what kinds of things did this guy get from player. So when we look at player, we see that this guy does have a get the current room. So we can ask a monster to give us the current room that he's in because a monster got everything that players have, and players already have that ability. All right. So back here in room, we can do this. So we're letting a monster know that the room he's currently in is this room. Remember, this is how an object refers to itself from within itself. So in this case, the this keyword is the instance of room we're currently in. So we're letting the monster know that they are in this room. All right. So now the room knows about whether or not there's a monster there. The monster knows about the room they're currently in. Well, we want the monster to be able to choose a random exit for the monster to take. Who knows about the exits? The room that the monster's currently in. So we need to be able to get at that room and then get at the exits in that room. And I guess go from there. So one thing we could do is rather than extract all this information from room into our monster controller, where maybe in our monster controller we say, okay, well, give me the room you're in, then room, give me the exits that you have, and I'll go ahead and loop through all those exits and randomly pick one of them based on my dice roll or whatever. Then I'm going to use that exit for the monster to move from this room into that one. We could build that logic into room. So we could add to room a new function, public void take random exit. And let's go ahead and say, why don't we take in who's taking that random exit? Well, we really want this to only work for monsters. Take random exit for monster. That way he doesn't need to take in any parameters because this room already knows about his monster. So inside here, and I do see the time, thank you. So inside here, we would ask the question, if this dot the monster is not equal to null, select a random exit from this room's exits and have the monster enter that room. So in here, we have our collection of exits. We have our current number of exits. So for your homework, what you're going to do is write the code to pick one of the random exits and have the monster leave this room and go into that room. Okay? So from the player's perspective, since the screen is not updating in real time, the player won't necessarily see that they've left unless we just put a little message in here. But we could go and have the player go and try to find you should be able to wander around the dungeon and find out where your monster ended up, because as long as if you wait 5 seconds, he's potentially had 5 opportunities to move. Go ahead. The monster is a player, which means he has everything that players have. Players know the current room they're in. And that room got set by room letting, whether you're a player or whether you're a monster, letting that, they let you know about the room you just went into. So that's how a monster knows about the current room they're in. All right, so your homework will be to implement this function right here. I'll put it up on Blackboard here in a little bit. So verbally, what are you going to need to do? Well, you're already in the room that the monster is currently in. So you're going to have to select randomly which of the exits you want to take, the exits that are in this room. Then remove the player from this room, remove the monster from this room, add them to that destination room. And then if you want, you can spit out to the screen that the troll has left to the north or something like that. You don't have to. Just your monster should move rooms for the assignment. And then if you want to go chase them down, you can. Cool? Questions, comments, concerns, bribes? All right, I'll give you this code as a starting point. I'll put the assignment up probably in about an hour. I have a meeting I have to run to right now, but I will see everybody on Friday.
So I've been asking these questions about access and stuff,
Mhm.
because an issue I've historically had is